Yesterday we talked about level 1. We talked about what is an x and y intercept. So just as a quick review, an x-intercept is where the graph crosses the x-axis, and a y-intercept is where the graph crosses the y-axis. And we always write the x and y-intercept as points. Now, a level 2 gives us an x and a y-intercept and asks us to actually graph that on the coordinate plane. Now, there's an important distinction I want you to pay attention to. You may be looking at this and saying, but Mrs. Rodriguez, you just told me that an x and y-intercept are always written as points, and I don't see these written as points. Why can't I write it like this? These are not written as points because we are testing to see if you know what an x and y-intercept is and where it's located on the graph. If I actually wrote these as points, I'm not asking you then what is an x and y-intercept on the graph. I'm just testing your ability to be able to plot single points. Okay, so they're written out of the normal correct form for the particular purpose of seeing, do you know where an x-intercept would be located on a graph? Okay, and that answer, remember yesterday we talked about it's where it is on the x-axis. So if it tells me that it's at the x-intercept of 5, that means that it is on this axis at 5. And that means that it is at the point 5, 0. We briefly talked about at the end of yesterday that all x-intercepts have a value of 0 for their y-coordinate when they're written as a point. And then all y-intercepts have a value of 0 when they are written as a point as well. So we have a y-intercept at -3. That means you need to know that this is really the point 0, -3. It is on this line at 0, -3. So the only thing that we're asking you to do is write them as points and then plot them. So 5, 0. 0, -3, and then we are going to connect those dots. Just as we did when we were graphing with our tables, we are using a straight edge to connect these dots because I should be able to use these lines to predict other points that maybe weren't plotted on here. So use a straight edge. Your ID, you may use a ruler from the back of the room. You can use the edge of your binder, but it must be some sort of a straight edge. Just like when we were graphing with tables and the domain was all real numbers, we are going to connect these dots. We're going to go all the way across the graph, not just through those 2 points, and end in 2 arrows. Okay? Let's take a look at the next one. It says x-intercept of -2. That means that it is at the point -2 for x. And because it's an x-intercept, y is 0. Then a y-intercept of 3 means that there's going to be a 3 in the y position and 0 in for the x position. So let's plot these 2 points. We have -2, 0, and 0, -3, or sorry, 0, +3. And then we're going to connect those dots with our straight edge. All the way across the graph, ending in arrows. Okay, that is what a level 2 is asking us to do. So level 1, they give us a graph that looks like this, and they're saying, hey, what's the x and y intercept? And you have to give the points. Level 2, hey, here's the x and y intercept. Do you know what that means? And can you plot them? So let's see what a level 3 is. It's kind of putting those 2 levels together. We are going to be given an equation and asked to actually find the x and y intercept and then use those to graph. So when you are looking for the y intercept, you're going to do the same thing every time. And that can come from that pattern that we talked about with the y-intercept. That pattern was all y-intercepts have 0 for the x-coordinate. So if I'm trying to find the y-intercept, we will always plug 0 in for x. Then we're going to solve it out to find the y, and of course, write it as a point. That means if we're trying to find the x-intercept, we're going to do the opposite. All of our x-intercepts had 0 in there for y. So we're going to plug 0 in for y. So let's practice that. We'll first find the x-intercept. So here is our equation, and with an x-intercept, we are going to put 0 in for y. So I have 2x minus 3 times 0 equals 18. And that's because I already know what my point is going to look like. It's going to have a 0 here, and I'm looking for what is this value. So I have 3 times 0, or negative 3 times 0. That gives me just 0. And really, yes, you can write it like this, but really, you know that anything plus 0 doesn't change. So we can take and write it just with that 2x. That whole term right here just goes away because it equals 0. So we're left with this 2x equals 18. Divide by 2 on both sides, and x is equal to 9. That means that my point, or my answer, is at 9, 0. Now we're going to follow that same process for the y-intercept. But instead of plugging it in for y, we're going to plug 0 in for x. And that's because we already know that my equation is going to look like a point, or my answer, is going to look like a point. And we already know because it's a y-intercept, that point will have 0 in for the x. So let's plug in 0 for x. That's kind of why we spent all of that time in the previous standard plugging in values to find out what the other coordinate is. It's because it kind of sets us up nicely for other kinds of graphing, including finding that x and y intercept. So I plugged 0 in for x into this equation, and I have 2 times 0, which is 0. So again, you can write it like this, 0 minus 3y equals 18. But does this 0 change anything? It absolutely does not. So I'm left with a negative 3y. Now be very careful because this negative needs to come down with it. A lot of us forget that negative as we're going along. So I've got negative 3y equals 18. So I'm going to divide by negative 3. Divide by negative 3, so y equals negative 6. So I'm going to take that negative 6 is my y coordinate. So finding the x and y intercept, we did it. It's 9, 0 for the x intercept and 0, 6 for the y intercept. And we can use that then to plot them just like we did in level 2. So let's practice this again with the next equation. The x intercept. We already know we're going to write it as a point. We already know that 0 is going to be my y coordinate. So I have negative 4x plus 0 equals negative 8. Negative 4x plus 0 is just negative 4x. So I have negative 4x equals negative 8. Divide by negative 4 on both sides, so that x is equal to 2. So my x-intercept is at 2, 0. Now let's do the y-intercept. we know that all y-intercepts have 0 for x and a number in there for y. So here's my equation. I'm going to put 0 in for x. 0 times -4 is just 0. So this might be one of our favorites of all because I am already to the point that y equals -8. So my y-intercept is at -0, -8. Now, you might notice as you go through these that there's kind of a little bit of a shortcut. When we put in this 0 here, it's like that whole term disappears, and I'm left with 2x equals 18, which we can solve. You can do that straight from the beginning. If I'm putting 0 in for y, that whole term is gone. I have 2x equals 18. That means I need to divide by 2 on both sides. Okay, if I'm finding the y-intercept, that whole part goes away. -3y equals 18. Remember, that's what we had here. And I needed to divide by -3 on both sides. I really encourage you guys to write it out like this a couple of times until you get comfortable and understand what's going on. Then you can kind of move to that skipping steps thing. I really don't want you to get to that point first because some of you guys sometimes still struggle on knowing what to do next when solving an equation. So you really need to make sure you know how to do this part first. Okay, let's do C and D together. So find the intercepts and then we're going to use them actually to graph, and that's really what your focus is going to be on your classwork. So if I want to find the x-intercept, I know that my answer is going to be a point. I know that 0 is going to be in there for y. So I'm going to put 0 in for the y-coordinate. And that leaves me with 3x equals 27. So I need to divide by 3 on both sides. So x is equal to 9. So my x-intercept is 9, 0. Let's find that y-intercept. We know that because it's a y-intercept, it's always going to have 0 in for x, which tells us also how to find it. We're going to put 0 in for x. So 3 times 0 minus 9y equals 27. So that 3 times 0 minus 9y equals 27 means I'm going to be left with -9y. Please don't forget to bring that negative down with it. Equals 27. Divide by -9 on both sides. And that gives me -3. So my y-intercept is at 0, -3. So those 2 points are the 2 points that I'm going to use to plot. 0, -3. And my x-intercept at 9, 0. Straight edge to graph. All the way across the graph, ending in arrows. One more together, and this one has fractions. So we have the x-intercept. Because it's an x-intercept, we know that our 0 will go in for y. So that means that this whole middle term here is going to go away. We'll be left with 3x equals 3. 3x plus 1/2 times 0 equals 3. 1/2 times 0 is just 0. So 3x equals 3. Divide by 3 on both sides, and x is equal to 1. So my x-intercept is just 1 0. Now let's find that y-intercept. Because it's a y-intercept, 0 will be in for x, and that will help inform me how to solve it as well. If 0 goes in for x, that means that whole first term is going to go away. 3 times 0 plus 1/2 y equals 3. 3 times 0 is just 0, and I have 1/2 y equals 3. So that means I'm going to multiply by 2 on both sides to get rid of that fraction. I have y equals 6. So my y-intercept must be 0, 6. 0, 6, plot the point. 1, 0, plot the point. And then connect those lines or those dots with a straight line from a straight edge.